This is a short video explaining the procedures to our extraction of an acidic, basic, and neutral compound for our organic chemistry class. In this laboratory, a small amount of solid compound that contained a possible combination of an acid, base, or neutral substance was obtained and had to be initially dissolved in diethyl ether, and then separated and extracted using NaOH and HCl aqueous solutions. Once extracted, the samples had to be tested for their respective melting points to determine what the substance was. There are a couple of theories being used for these extractions. One theory is one that we're all familiar with by now, which is that like dissolves like. So polar would dissolve polar and nonpolar would dissolve nonpolar. The substances that we were testing for were made out of organic or nonpolar parts, as well as a polar end. In order to separate the initial mixture and test for a base, a 5% HCl solution was used to react with the base. Since an acid and a base form a salt in water, the idea was that the hydrogen ions would bond with the organic base at its polar end and make it soluble in water. Then this aqueous solution of chloride ions and the organic base would be transferred to a separate centrifuge tube where a 10% NaOH solution was added for back extraction. In back extraction, the compound is changed back to its initial form, which, due to the solubility rules that we discussed earlier, would cause the substance to show in solid form, or a precipitate. The base, when it was in ether, was soluble because the organic part of the base was much larger in size than its polar end was. But now that it was transferred to an aqueous solution and mixed with NaOH, the extra hydrogen ion is removed and it goes back to its original state. Hence, since it was now in an aqueous solution, it would show its presence as a precipitate because it's not soluble in an aqueous solution. My compound did not have a basic compound, so we proceeded with the next step, which was to extract for an acid. As you can see, the litmus paper turned blue, which means it's basic, but no precipitate was there, so we concluded that there was no base present. In order to extract the acid, we went back to our first centrifuge tube and added aqueous NaOH. The NaOH would react with the organic acid's carboxyl group and make it soluble in water by removing a hydrogen ion and giving its oxygen a negative charge, thus making it soluble in water. This aqueous layer was also then removed and put in a separate centrifuge tube to be back extracted. For this back extraction, 10% HCl solution was used to react with the organic acid. The HCl donates the hydrogen ion to the organic acid. This would change the organic acid back to its original form, which is not soluble or less soluble in water, turning it into a solid or a precipitate, which I then filtered. This precipitate was stored and I allowed it to dry completely in order to check for its melting point later. The last one of the remaining compounds that we tested for was a neutral compound. All we had to do for this last step was to transfer the remaining ether into a small flask, add 1 ml of water to wash it, and then add sodium sulfate, which was a drying agent that absorbed all the water that was in the mixture and left us only with the ether and the neutral compound, which should be dissolved in there. The solution was filtered using a pipette, to which we added some cotton to prevent some of the sodium sulfate to go through into our final product, because this would alter the melting point results when we tested the neutral compound for its melting point. Once filtered, the solution was heated in a water bath in order to evaporate the ether and leave us with only the neutral compound to weigh and test. And this was what I got, which was a white precipitate. During these extractions, I obtained a pearly white acidic compound and a white neutral compound. When tested, the acidic compound was determined to be benzoic acid, and the neutral compound tested in the benzyl range, even though it was probably not benzyl, since other tests that yielded benzyl resulted in a yellow precipitate, not a white one. The results could have been affected due to not being able to accurately extract every drop of the aqueous solution during the extractions. And it is a very small volume, and even the slightest relaxation or contraction of the fingers could release the solution or absorb some of the unwanted solution. This could have affected our melting point results. Another error that could have altered the results was what happened to me and the pipette bulb. When I was mixing the solutions, the bulb shot the pipette out, and this resulted in having broken glass at the bottom of the centrifuge tube. This made it even more difficult to extract, every last drop of the solution being extracted without getting some of the unwanted solution. Another error could have been that water ended up inside the flask when in the neutral solution when it appeared that all the water had already been absorbed by the sodium sulfate. This may have affected the results of my neutral substance melting point, since any impurities lower the melting point of the substance that you're testing for, and mine was off by 9 degrees Celsius. I had concluded that the neutral substance was benzyl, when in fact it was phenanthrene. It is possible also that the glass could have affected it. Something that I would have changed in my procedure would be using both hands to use the pipette, and maybe instead of heating the neutral solution with water bath, you could have heated it directly, put the flask directly on the hot plate. So like I stated, when the melting points were tested, I concluded that my acidic compound was benzoic acid, since it was only off by 3 degrees Celsius, and the other closest compounds were at least 11 degrees lower or higher. And the neutral compound was not benzyl as concluded by me, it was phenanthrene. My melting point for that was off by 9 degrees, and my percent recovered was 94.4%, which is pretty high compared to the other classmates. But I think it may have had something to do with the impurities in the neutral compound. So this was how I conducted my lab for extraction, part 2, for organic chemistry. Thank you guys, and see you next time.